welcome to MATHurdays. Math's so fun that we do it on Saturdays. I'm going to go ahead and make sure that I share the link to my slides to all of you. And the link sharing is in the chat box. And you'll notice there are a couple of really useful links on that very first page. You can send me an email, head to my website, follow me on Twitter or YouTube. I am trying to get all the resources that I've used over the last 10 years available to teachers for free so that you can use them in your ever-changing teaching curriculum. On slide 2 is the program that I teach in at George Mason University. Again, I've been an online teacher for 10 years now. This is an example of my normal, and I hope to give you some ideas for your new normal. On slide 3, all of the templates from this session and any other session you've ever seen are available on my website. I also include video recordings of each session, the templates, and just general tips for educators. And if you would join me down on one of the successes and celebrations slide, we have a rather large group today, so I have 3 slides available for that. Slide 4, 5, and 6. If you would please use a text box and share something that you are celebrating today. As a heads up, the text box, there's a little purple arrow pointing to what that looks like, and it's up on your toolbar. And then I'll ask a couple of you to turn on your microphones and share with us a little bit about these successes. And I'd like to start off with Michelle because she's got some amazing resources for us all the way at the very bottom. Michelle, can you go ahead?
Oh, sure. Because I've been learning through you, trying to make my lessons pretty interactive, we did a community builder on slide 39 where they type their name, their favorite video game, and a board game. And so it's just something fun. It's kind of like a check-in, so you make a couple of duplicates. On slide 40, we were doing area and perimeter, and just to start them off, we just did what are the similarities and differences, and they just type in those little rectangles. And then on slide 41, we were doing another community builder with Would You Rather? And again, it's just to get them used to inserting text boxes and communicating because it's hard to see everybody when you can't see them. So.
Yeah, absolutely. Wonderful. Thank you so much for sharing that one. We've got some gardeners. Tiffany, how's it going?
Well, we planted our squash and the zucchinis in the garden, I don't know, a month or so ago, and we've already got tiny fruit starting that's been pollinated, so we're excited.
That's awesome. Lily, tell us a little bit about the color choices that you did in your work.
Hi, Teresa. Good morning. Because I teach math in a Japanese immersion setting, we talk about colors a lot to show and describe our feelings. And rather than asking them directly, first, how do you feel about distance learning to my 3rd and 4th graders, I thought that maybe using the colors might show their emotions a little better. And to my surprise, they chose yellow, which is my least favorite color. But the reasoning was that the yellow is usually sunny, bright, fun color. So that I was really glad to hear that they were enjoying the interactive nature of our class. So thanks to all the templates and the wonderful PD sessions. Thanks, Teresa. Happy Teacher Appreciation Week.
Oh, wonderful. That's so exciting to hear. On slide 5, Laura's got a little video here. Tell us a little bit about the games and how you created it and how the students enjoyed it.
So I was inspired by so many of your sessions, Teresa, to try to apply not just the interactive element in like my lessons, but try to do something fun during office hours. So I just took a blank Google slide and just inserted a table, like a basic 4 in a row multiplication game. And I just made some circle shapes for them to like have as counters to move around the board and some arrows. So just basically using Google Slides, but just trying to incorporate the interactive element, and the kids loved it. I have kids who would come to office hours every single day this week just to play. So thanks for the inspiration.
That's really incredible, Laura. Laura, if you would like to share, I would be happy to post that and any other templates that you all do on the website so that other people can access it and, of course, give you credit for it. If that's the case, just put it right on top of the virtual parking lot, and I'll be sure to link that there. And Raha, tell us about your students and office hours.
Hi, Teresa. Good morning. So I teach in a SPED inclusion classroom. So my students have two teachers, and a lot of the SPED kids have to juggle a lot of more work than they need because they have small groups and they have tier 1 instruction. But they have been joining me. They'll tell me, like, I'll see you at 1, and they'll come to my office hours just for some support with tier 1 instruction. So they're advocating for themselves, which is really exciting. When we were in the classroom setting, they weren't doing as much, but now I think now that they're away from the classroom, they're kind of appreciating all the work that we do together.
It sounds like you are a wonderful support to them. Thanks for sharing. And Diane, tell us about this incredible record of 15 out of 15.
Well, I was so excited because I teach an advanced math / regular 6th grade math class. And since I've been using Pear Deck and Google Slides, my kids have realized that they want to come to class. And we had 15 out of 15 for the last week coming to class and engaging in math. So I was just thrilled. So I'm here today to learn how to make it even more engaging so I keep my 15 out of 15 coming.
That's incredible. Thanks for sharing, everyone. So this is Successes and Celebrations. I never host a PD without doing this. This is one of the most important things in building relationships and community in your class. It's a nice, open, unstructured space, much like indoor recess, for students to be able to write if they want to write. Every student gets a voice, and you can write a lot, a little. There's no structure here, so it's really open for creative interpretations, and we even get some cool videos, GIFs, or images, so there's lots of ways to participate. Alrighty, we're going to roll right into our math. I have a familiar routine for you all on slide 7. This comes out of Steve Wyborney's materials, and the link is below in the presenter's notes. But Steve works a lot with this routine called Splat. And what I've done is try to find ways to put them up on Google Slides so that they are easier for you all in creating it with your students. We'll do a couple examples and then you all get some hands-on time. So slide 7, there are 12 pink circles on the slide. How many are under the splat? Feel free to write in the chat box. Awesome. I'm going to go through this routine rather quickly because, again, I'm not modeling it for students, I'm modeling it for teachers. Come on down to slide 8. Slide 8 says there are 34 blocks on the slide. How many are under the splat? Go ahead and make a response in the chat box. Wonderful. And of course, at this point, I could ask you all questions about this routine. How do you know? What's your hypothesis? What if I add one more group of 10? And this routine, if you check out Steve Wyborney's website, there's a lot of great talking moves there. But in this case, I'm not teaching teachers how to teach. I'm teaching you how to tweak what's online. So come on down to slide 9. And on slide 9, there's 47 cents on the slide. How much is under the splat? And if you respond, would you also respond with what coins you would use? And again here, we might actually bring a dime and a penny over to the splat, reveal it. We might ask some guiding questions. Are there any other coin combinations that you could do, etc. Slide 10. So our secondary folks here, these are algebra tiles. If you're elementary, the thing to know is if it's red, that means that it is negative. So there are 2x minus 3 tiles on this slide. What's under the splat? The long green ones are considered an x. The long red ones are a negative x. The little yellow squares are 1. The little red squares are negative 1. And it seems like several people had said 4 red squares. I'm going to ask if somebody could turn on your microphone and answer this question for me. How on earth is it that we have 4 red squares when the only numbers in our expression are a 2 and a 3? How might you answer that using this Google slide? If you turn on your mic, if this is something you teach or something you know how to continue. How is it possible that I'd have 4 red squares when the only numbers up here are a 2 and a 3?
A red and a yellow turn into a 0 pair. So when you have one positive and one negative, when they are working together, they become 0 pairs. So, oops, I think we were both trying to move it at the same time.
Yeah, you
So
go ahead and
a
put them
red,
on.
okay, so a red and a yellow together makes a 0 pair. And so that's how it happens. That's how it works.
Very cool. And then we could get into conversation about what is a 0 pair? Is there such thing as a 1 pair? Is there a negative 0 pair? Oh, the conversations could continue. Awesome. So we have this routine. I think generally speaking, our primary teachers know the routine, but maybe our secondary teachers or our upper elementary don't. So I'm going to offer, there are 12 slides below. We do have 42 people, so we'll just kind of let everyone explore. If you want to head down to a slide and feel free to explore what it's like to use those tools. And as you do that, I'm going to, at the same time on the recording, talk about the infinite clone. This is something that our teachers have been asking for quite some time. You'll notice on the left-hand side, I have left for you some tools that you can pick and drag over, and they are kind of cloned. They leave an old one behind it, and they don't seem to run out. Well, the trick to this is actually they do run out. It's not an infinite clone. Instead, it is a very large number of copy and pasted pieces right on top of each other. But if we look at exponential growth, it won't take long to get these. You would just take the shape you need, copy it and paste it again, put it right on top, highlight the 2 that you have now, copy and paste those, put them right on top. Google does a nice job of giving these little red crosshairs so you can see if they are. And you can very quickly make a whole bunch of them. Raha, go ahead.
So I was trying to figure out the cloning too, and I have another way of doing it. Do you mind if I share?
Awesome. Yes, I'd love to hear. What slide are you on?
I'm on slide 21. So if I am holding onto a picture or a shape and I hit Control D multiple times, it already makes a bunch of clones like that.
Ho, 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 ho.
And then
Cool.
what you would do, you would kind of highlight the clones that you made. So you would kind of drag your cursor. It's a little tricky. Can I move the splat?
Mm-hmm.
So like you would highlight the clones you just made, and then you would hit right click. I'm just going to move this one. Sorry. You will hit right click, then you would say align horizontally, and you would do left, and it lines it up like that. And then you would right click again and you would do a line vertically into the top. And then it's cloned. So if you move away, you can take one at a time. And if you want to make clones of the clone, you can do that too. The one thing caveat is like after like 2 clones, if I keep cloning, it slows down the slide. So I just make my first clone a lot more. Does that make sense?
It does.
Yes.
Thank you so much for sharing
You're
that.
welcome. Of course.
Awesome. All right, it looks like we have some splats. So I'm going to kind of just go in order and give us a chance to see if we can see what's below. So it looks like slide 13. There are 10 pink circles on the slide. How many are under the splat? And slide 13, there are 10 pink circles on the slide. How many are under the splat? Cool. Oh, and they're changing too. Slide 14, let's say there were 22. How many would be under the splat? Let's see what other fun ones we have. Something's coming up on slide 20, so that's going to be up here too. All right, I want to throw it out to you all. You all are the pedagogy experts. How might you use Splat in your math classroom? Go ahead and turn on a microphone and tell us about how you might use this, whether you are a primary, elementary, or secondary teacher. Go ahead, Laura.
I could see this using this like as a number routine to kind of launch your math lesson, particularly if you're working like in 4th grade, we might be working with multiplication or place values, so we might be using some quick images just to kind of get their brains primed for the main lesson.
Wonderful. Go ahead, Patty. Patty, go ahead.
Sorry, I forgot to put my mic on. I was going to say the same thing, just like the lady said before me, that just as a warm-up they love. And I have 29 kids in my class this year, and they all get into doing this kind of thing because they can do it in all different ways. So as a warm-up, mostly.
Wonderful. Melissa?
I could see this in a breakout room as an activity with small groups, and you could differentiate the tasks and you could assign kids to rooms. So you could have different tasks for different rooms, and then they could report back about their strategies in solving.
Ooh, very cool. Raha?
It could also be language development and writing practice. We in 4th grade have been doing number sense routines, but we have also used your ONA space where the kids get their own box and type in what their prediction is and why. So it gives them some domain to like practice their language acquisition for ELL students.
Absolutely. We have the space. You can keep making more slides. So it's great to be able to include language and even other content areas. Someone's been working hard on slide 20. Let's take a look at that one. There's x squared plus 4. What's under the splat? If you all want to make some predictions, feel free to. And at the same time, over the microphone, if there's 1 or 2 more ideas on how you might use this. We've heard as an opener, we've heard in small breakout rooms. Thank you, Nick, for putting that in there. Connects with communicator.
I think you could also have the kids create their own, whatever you're studying, fractions or algebra tiles or money, and then have them create it. So when they create it, then they truly understand it.
Michelle, that was one of the things that I love most about the interactive slides is that there is so much opportunity for the kids to take ownership of the learning. So if I were to tell you to create a slide and make it the trickiest slide you could, like think of something really tricky. What I'm actually doing is motivating the students to show me the like the ceiling of what they know. What is, so if they're in the algebra tiles, they might be working a lot with positives and negatives, where maybe I wouldn't have known whether or not they knew about positives and negatives before it. So yes, exactly. All right, folks. Like Raha mentioned, there are some downsides to Google Slides, and one of those is that when you have a lot of images on your slides, they can get a little laggy or slow. So I have made a copy of this. We will have a copy available on my website later also, but I'm going to delete out the splats for now just because they have lots of images of coins, etc. on there, but you will get access to them. And so I want to make sure you all knew that. They're not going away forever. All right, and then we're going to talk about rich tasks, why we do rich tasks, and our rich task for today. So on slide 7, if you join me there, this is what NCTM says in their Principles to Actions are the 8 math teaching practices. Take a minute and think about what's something you're really good at and what's something you could really improve on. And then join me on slide 8. I challenge you today to go outside of your comfort zone. If you are really good at, let's say, abstract notation, try something that's pictorial or a virtual manipulative or concrete. And I promise you, you all have concrete manipulatives at home. You probably have some Cheerios or pasta laying around, and those make great manipulatives. On slide 9 is the problem-solving oath I always give my students. I ask you to read this oath, and if you pledge to it, please type your name in the chat box. Look at all our amazing problem solvers today. Our task is on slide 11. And thank you to all the English language learning teachers who commented on previous sessions that we really do need to use the affordances of Google Translate. So if you would like to hear this read to you aloud in English or home language, just click that little link there. Infinity Hopscotch is a company that paints hopscotch templates on blacktops around schools and parks. They have become popular for their incredibly long hopscotch courses. Some are hundreds of numbers long. What do you notice and what do you wonder? Please type a notice wonder in the chat box. Diane, I think I also noticed it was long and I was going to get tired. Shala, I like your question. Is it made of chalk or paint? All right, let's go ahead and get into our task. On slide 12, this is our actual task for today. You're going to be in breakout rooms to discuss this. And here is the problem. Your school wants to unveil a hopscotch course on the 100th day of school. If this pattern continues for 100 boxes, what is the placement of the 100th box? Does it make sense to end at 100? And there is an optional one if your group finishes early. But really, this school wants to do a really cool unveil. And they want to know where that 100 one's going to be, if it makes sense. On slide 13 are some virtual manipulatives to get your minds rolling, and I'm going to create breakout rooms and place you in them automatically. If you are familiar with Collaborate and you know how to identify your breakout room, feel free to go ahead and get started on that. If you're not, don't worry, I'm going to come in and check in with you. All right, our breakout rooms will start in 3, 2, 1, now. Hi folks, you're group 1. If you want to turn on your mics and introduce yourselves, you're on slide 14.
Thanks, Teresa.
Or is like day 2 adding numbers 2 and 3.
Hi folks, just a heads up, you are group 2. You're going to be on slide 15.
Thank you.
Oh, does somebody want to project it? Should we? You could project it in here too.
Oh, I don't know how to do that.
Hold on, let's see.
How are you looking at the problem at the same time? On a
Did
different
you open her Google Slides?
Well, I have a different tab for that.
Need to continue the
Or we could do visuals where it's the first 10, you know what I mean, and then break it into 10 chunks. So we could do that. So we could do like
yeah, and I also feel that like if you take 100 numbers and you do
Can say maybe is that if you look at the pattern, it's 1, 2, 3.
All right. So how could we show, can't remember who had said earlier that 99 would be, if it's multiples of 3, then the 100 would be off by itself and the 99. Like how could we show that thinking?
Should we maybe snag a picture of 1, 2, 3 and then use the same format that you guys used for group of 4 so we can have a group of 3? Should we do that?
Yeah, that sounds great. That way we show that we're capturing that idea.
Yeah, I can do that. I can use the picture you guys gave us and then I'll just snag the 1, 2, 3 part and then put that next to it then.
Perfect.
There is a 1, 2, 3 group on.
and then I might also continue to, you know, fill this out.
7, 10,
20.
13.
Yeah, what would,
19.
I think I have to draw. I know there's some kind of pattern, but
10 is shifting.
Oh.
Middle 10, left 20, right 30, which means middle 40 should be next, right?
The 40 should then be in the middle again.
So
So what if we
50
make like
left. We can make one out of 10s, yeah.
70, 80, 90. So 100 would be in the middle. Because if it's middle, so like if 50 would be back to the left, 60 would be right, 70 would be middle, 80 left, 90 right, 100 would be back in the middle.
Hi there,
I'm
team.
just looking at a table over to the side.
okay.
This is a really neat generalization that you guys are starting to make. My question to you, how do you know this about the 20 and the 30? What's your evidence of that?
I think I connected with the 30. Is it because on the right side, I was trying to look for those generalizations. I think that they're multiples of 3.
Yeah, or if you multiply each square by 10, it gets back to the same position.
Ooh.
So like 3 times 10 is 30, and that gets you back to the right-hand side.
So that's another neat idea. Here's my question for your group, because you all are on to some really cool stuff. I see a visual where you have it up to 12. And then I see this great idea about moving up to 100. What I'd love to be able to anchor it with is, what does it look like if it goes to 20? What does it look like if it goes to 30? That's like that middle zone. How do I bridge from the very concrete of 10 all the way up to this big generalization? So I'll challenge you all to try and think about ways to make it so that we can see that.
Okay.
Oops.
So we could put just those, that up to 10, you could make that 10 times side by side
Ooh, yeah.
without having to put it all on top of each other. And I would do that, but I have no idea how you're doing that.
Oops. Oh my gosh. This went off the screen. Sorry. Ah.
An idea. Whatever else is doing, she's cool with that.
And slide 13 lists some virtual manipulative, so.
Hi there, group. How are you?
We're trying to figure out how to pull in some of the other modalities.
Oh, very cool.
I don't know. Our group just kind of all saw it the same at the same time.
So you saw this like cluster of 6, is that right?
I saw the groups of 3, making it 99, which means 100's on top.
Okay, so groups of 3, and then someone else saw groups of 6.
Yeah, I saw a group of 6.
Now, I'm curious because the way I see a group of 3, let me clone what you have here.
Yeah, I'm looking at that thinking I need to put the one on the bottom.
I'm a little kind of unsure, because when I see the group of 3, I see it like this. I see the bottom and then 2 in the middle, but you're showing 2 in the middle and a top. And so I'd like for you to kind of walk me through, how is that, how might you change my understanding or help me to see it the way you have it?
I just fixed it. So maybe that's it, like that.
Okay, explain to me why you fixed it and what it means.
Well, here's my group of 3, 97, 98, 99, and then 100 would be on top.
Ah, okay. Neat. All right, feel free to keep working with those virtual manipulatives, and if you all need more space, just add a new slide.
Cool.
Hi there, Group 4.
Hi.
So tell me about odds and evens.
Well, we had several thinking going on here. We had, we were chunking them in 10s, so that's what the blue and the yellow Unifix cubes are on 17. And we realized that the yellow top 10, so the next one 20, and I forgot who I was talking to about that. You didn't do it with visual.
Yeah, I'm more of the abstract thinker. And so I first solved it abstractly, but then kind of checked my work with more of a concrete model or table.
The table. So we put in the table every single. So 1, 4, 7, that's the number that would be in that single one. She checked her work, and then we had somebody say that every third square is a multiple of 3. So it would be 99, and then the top one plus the 1 would be the 100. So 101 would be off to the side.
Cool. I'm intrigued by the pattern of the blue and yellow pieces. Is that pattern useful to you all, or is it kind of just really neat to see?
It was useful to me because I'm more of a visual learner. So I had to see like blue was odd, yellow was even, and I could see it going up, and then I could like make a prediction that my top number has to be even. So my cricket number has to be, I don't know.
It's really neat because, yes, it does. That single one does go even, odd, but it's not like 1, 2, 3, 4. It's 1, 4, 7, 10. And that's just,
Right.
that's tough to wrap your mind around. Very cool. I love the visual there. And if you all need more room, just add a new slide.
Okay.
But
Thanks.
if we divided the single number by 3, then there's always one left.
Oh yeah, that was this one right here. Yeah.
Right. So
that definitely makes sense.
Divided
Welcome back, everyone, to the main room. Welcome back. Can you believe it's already been 21 minutes of exploring that problem? Welcome back, everyone. I have already muted your microphone, so if I ask you on your slide to speak, make sure you turn it back on. All right, folks, welcome back. What I'm going to model next is how to hold a discussion, and I'm using Smith & Stein's 5 practices. There's an example on slide 20 of the steps that I'm taking. I've already developed a rich task that has a lot of entry points, a lot of ways of solving it. I have anticipated already 16 different ways I expect people to solve this problem. I've monitored by going into the different breakout rooms and asking you all some questions. I've also, during that time, selected out which are the examples that we're going to go over. And spoiler alert, we're not going to go over everybody's. And also, when I head to your slide, we're not going to talk about everything on the slide, only the specific ones that were selected. I've gone ahead and sequenced those into today. What I'm going to look at are math progressions from students looking at patterns all the way through Algebra 1 concepts. And then we're going to make connections to those. So I hope you all are excited to see the way these 5 practices pan out. And we are actually going to begin on slide 16. And again, I know many groups have lots and lots and lots of examples on their slide. And I'll ask that you share with us the sample that the arrow is pointing to. So group 3, how did you use the hundreds chart?
So we took the idea that there was definitely going to be a pattern with this, and we decided to use the hundreds chart thinking that we were going to be skip counting basically by 3. So you can see that we started doing that in the first 4 or 5 rows there, and then we're able to extend the pattern ourselves just by mentally and looking at that, and figured out that we would end on 100 using that.
Neat. So you were able to use that hundreds chart. I can almost see a pattern emerging. Did anyone else see a visual pattern here? It's pretty cool when you notice it. Yeah. So that can be really neat, and we could have conversations about how that is influencing our guess about that 100. Let's check out group 4. They are on slide 17. And group 4 has a lot going on here. The thing I'd like to start us off with is the table that they used. And for everyone else, what you're going to write in the chat box is, how is this table similar and different from slide 16? Group 4, can you tell us what this table is all about?
Sure. So we started off creating a table to kind of indicate what digit would go, or what number would go into the single tile category. We initially did it up through 43, continued it on to check as we progressed through some of our other representations.
So in the chat box, your all's job, how is the green table similar to the hundreds chart? Put that in the chat box. And I'd like this group to also talk a little bit about their color coding of these blocks.
That was me. Let me see if I'm unmuted. Okay, yeah. So the blue is odd and the yellow is even. And I was just looking for that pattern, which is similar to the one in the hundreds chart, because it's all going diagonal the same way you did, or somebody showed that line. And so we did 10 because that's an easy multiple of 100. So the 10, the yellow would always be on the top up to 100. I mean, it would be yellow, blue, yellow, blue, yellow, blue, and then we knew that the odd would be 101 off to the side. So I was looking at it more visually, and I think it was, let me see, Christy, she was the one looking more concretely and making sure our numbers matched the pattern. And then we had a third one.
So
a third person did.
So that's really neat that you had these color-coded pieces too, and that there's a diagonal pattern. Can someone else, if you see this diagonal pattern, what's your hypothesis? Do you think that the diagonals in the blue and yellow follow a diagonal rule for the same reason as the hundreds chart? What's your thought on those diagonals?
They might be. Let me go back. 16.
So we'll do all share for this. If you think you know, is that diagonal following the same rule? Turn on your mic and share with us. Diane, can you elaborate a little bit on your chat?
Diane Davis? There are two Dianes.
Oh, yes, Diane Davis. Go ahead.
Yeah, no, the diagonal on with the Unifix cubes were evens on the diagonal. And on the hundreds chart, they were every third number, so they're not all even.
Ooh, so diagonals might have different rules. I might have you all explore that one. That could be a whole conversation of our math talk. Very neat. Let's kind of continue this idea of diagonal patterns and join me on slide 14. 14 has another kind of cool pattern that goes with this diagonal thing. Look at there, 10, 20, 30, 40. And they also have a little table, which, guys, I'm going to move right on top of your numbers here. So they made this really cool table that went along with the 10, 20, 30, 40. Would you all share with us how the boxes and the tables go together? What's your thinking there?
Sure. So we used slide 12 and snagged the little hopscotch pictures that were already there and then started to continue the pattern. But when we got to a certain point, we realized like, oh, the 10 numbers or the multiples of 10 are shifting from the middle to the left to the right. So then we were able to just look at the 10s and follow that same pattern, which is the last hopscotch where it just has all the yellows.
Who from another group was able to understand how they merged that table to the concrete pictures of the hopscotch things? Could you rephrase for us? I'd like us to really see if we've understood what they're saying. Shala?
So they noticed that the multiples of 10 were falling in this pattern of where they were appearing. And so they followed that pattern after 40 to figure out where the rest of the multiples of 10 belonged. So the pattern is center, left, right, center, left, right.
Thank you. Yes, okay, I have clarification now on that pattern. So I'm going to throw it out to you all. Is this diagonal pattern related in any way to the diagonal patterns we saw on slide 16 or 17?
I'm going to put myself out there and say yes because they're both based on the base 10 number system. So our hundreds chart is rows of 10, and then I'm looking at their, sorry, I'm on the wrong slide. I'm looking at their hopscotch. It goes 10, 20, 30, 40, 50, 60, 80. That's also the base 10, so that it's counting by tens rather. So they would definitely be related because they're using the same number system.
Really interesting. Who else?
I was looking at the anytime like on our hundreds chart, anytime it's they have it in the middle, our hundreds chart, we had 10, 40, 70, and 100. Those are in the middle on theirs. And then I would have to look at the left, the ones on the left and the right. I'd like to look to see in which diagonal they fall on when they're not in the middle. So I bet that would line up.
Neat. So I'm going to task somebody, whoever's most interested in this. There are little left, middle, and rights now on top of slide 16. Make copies of those, move them onto those tens for 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. See if that helps us understand that pattern. And some people are probably going to be on those slides thinking about that pattern and developing that pattern. So we will come to you for that explanation. For everyone else, if we could head to slide 18. Slide 18 has something really interesting happening here with specifically this rule that they're talking about. Can you guys tell us your rule and how your rule developed?
Sure. So initially, I started thinking about as a numerical pattern because that's a fourth grade standard. So in my brain, I was like, okay, so between the singletons, the rule is add 3. And then we had Nick who took that rule and kind of thought about it as a multiple of 10. Nick, do you want to add on?
Sure, I can add on. I honestly, I just drew it out like I thought a kid would, and I started just touching the squares and going 10, 20, like this 10, 20, 30, 40, 50, 60, 70, like a kid would. And then Raha showed her rule over here, and I was like, okay, so the way I touched it, my rule would be plus 30, which makes sense because her rule was plus 3. And so but I didn't come to the rule until Raha showed her rule, and then I was like, oh, okay, and I made my rule.
So does that make sense that we could just say that because the first row is plus 3, that we could then say, oh, well, then the next one could be plus 30? Are we allowed to just multiply by 10 here? And if so, why?
Base 10 system, I don't know.
So there's something neat about our base 10 system. Let's go ahead and back to slide 16. I think we've got a group who finished that one for us. How does the pattern on slide 16 help us to understand slide 18? Mimi, could you tell us a little bit about the rules and how you see them clearly?
Sure. So on the hundreds chart, all the red slashes are the plus 3 rule. And then if you go down the tens column and look at all the M's, those are all the plus 30.
Cool. So we can clearly see here the plus 30. Anyone else have that moment of realization about the plus 30? And I would like to bring this back to our early algebra sense making on slide 19. If you join me there, we have an XY table, something that's pretty typical in Algebra 1. And would you all tell us about your table here? I'll put an arrow next to it, and how you might use this table to solve the problem.
Well, we were looking at it in terms of, I teach sixth grade math, and we were looking at making proportions. So when you looked at the groupings, we started making all these groupings, and we said, well, if we have one group, you would have 4 tiles, and then 2 groups would be 8 tiles. So we're looking at our groups of 4, and so we know that when we make a multiplicative table like this, you can actually make proportions. And so if we go down to the bottom, the proportion of 1 to 4 would be 25 to 100. And so what I tried to do over on the right was create a graph, and we kind of moved this over here. If you start graphing these as coordinates, so 1 to 4, 2 to 8, you can see I was struggling with the little dots, but here's x-axis and y-axis. So 1 to 4, and then 2 to 8. And then one of our friends found this. I don't remember who it was, but maybe she can help fill us in on finding the...
So the neat thing here is, regardless of how you see it, if you see it as even, odd, even, odd, even, odd, groups of 3, groups of 6, groups of even 4, which is really interesting. I'm going to leave that seed in your brains to think about even more, that we can make these proportional relationships, but they don't always come out as easily understood, or that question of, is this really multiplicative, should be kind of stirring in your brains a little bit. All right, folks. Well, that was it's kind of how we can have a conversation about the tasks. You'll notice today that I relied heavily on comparisons. I wanted you all to keep looking at patterns and compare whether those patterns had anything to do with each other. Those of you who teach multiples, there was a lot in here that you could do with multiples. You could do multiples of 2, 4, 3, 6, and so on. We even saw multiples of 10, so there's a lot in there with that too. Whatever your lesson is, you notice here that I could have focused on about 50 different things. I tried to do progressions, but you could focus simply on division. One group even did, well, 100 divided by 33 is, or 3 is 33 remainder 1, and there's a reason to talk about remainders. So there's a lot of different places you could go with this. When you have a discussion, try and focus it on one place, and if you think that there is opportunity for multiple discussions, great, just use it over 2 days, but keep your discussions a little bit separate so that students can come together and summarize at the end. All right, folks, that is MATHurdays. We are already at the end of our hour. I'm going to be down at the virtual parking lot on slide 26 to answer all of your questions that you might have. If you liked this PD and you want more, feel free to sign up. I do daily PDs with alternating topics every day, and every Saturday is MATHurdays. So feel free to sign up at teresawills.com/free-PD, and keep sharing your successes and celebrations on Twitter and social media when you have them. It's been a pleasure, everyone, and happy Saturday. I'm down on slide 26 if you all have questions. You all are very welcome. Thanks for coming. It's always a pleasure to nerd out with the math folks on Saturdays. Yes, every Saturday there's a new rich task and a new routine. So today was Splat and Hopscotch. Last week was Pokemon and M&Ms. So every week there's something new, and hopefully you guys can take some of this and plop it directly into your classes. Oh, somebody wrote a really good question and one that's near and dear to my heart. How do you support students who need quiet work time? Breakout rooms feel noisy. We have a norm in our class about using the away message, and it's not you're never penalized for using the away message. Instead, we talk about how it is a courtesy and your job as a digital citizen. So as soon as I'm in a breakout room, if I know I need 5 minutes to myself, I turn off my audio, I put up the away message, which is down by your profile picture. It's right next to your microphone. So I'll do it real quick. So I just put up my away message. I will turn off sound for everything. I'll even take off my headset. And it gives me a place where I'm allowed to be myself, which is somebody who needs a quiet space to think. Nicole, yes, all the previous sessions are recorded. Check out my website under MATHurdays and you'll see the Pokemon one. Oh, no, you didn't miss that. Whoever asked that question, that was, that's just something that I do without thinking about it. Let's see. I want to use this for my class for proportions.
That's Diane.
Oh.
So I have a question for you. So on 19, were we off in writing the proportions like this? Because I think this would be a great exercise for them to make into proportions.
Oh, so that's really interesting. It depends on the way that you're thinking about it. And I think some people in our audience were thinking of it. Let me move your tiles here. Actually, I'm just going to duplicate the slide. Okay, so on slide 20, I think some people were considering this to be 1. And then if we had another one, that it would be more like, let me ungroup these. Oh, these are just pictures. All right, let me go up here real quick. I think some people were thinking that on top of the 4, we would now have a single 5.
Oh, I see what you're saying.
So, and this
so it would have to be.
This isn't necessarily incorrect. It's just the way that some people saw it. But that will kind of, if that's the way you're viewing it, it's not going to work here. But it does work for every other. So if we were to add another, this is one of the anticipations actually that I had. So after a couple of them, it does start to work out, but not for every single one.
Got it. Okay.
So you'll notice here.
So you need 3 groups.
But you'll also notice that now that 12 is at the top, 13, let me grab these for us. So this is from another group. And you'll see that 13 would indeed be the next flat piece. So after 3 sets, you have reset yourself. And your next one really would be 13 as a single.
Right.
And this is a fantastic topic to talk with students about. It happened to not be the topic that I was going into today because it would need so much more attention. So after a certain amount of time, you can count by 4s, but only if you end up on some bigger multiple of 4 times 3, which means you would need a multiple of 12 in order to make this work. That happens to work at 99. So yes, this does work, but if you were to ask where does the number, let's say 90 go, it might not work.
Right. Okay. Okay, because I was thinking in terms of proportions. I have to sit and think through this, how I want to, because it would be a neat way to look at proportional, but this might not be the best way to do it then.
It might work.
Now that you've said that.
It might work for you really well if you look at it as a group of 3.
3.
So then it is quite proportional and it doesn't change. I'm going to keep
Right.
highlighting. So if we look at each group of 3 in
Right.
this sense, then I think it's where you want to go with your proportion lesson.
Okay. Okay. Thank you.
Yeah.
That's awesome.
Absolutely.
Thank you so much.
Mm-hmm.
And you said that these you'll leave a blank copy of these on.
Yes, if you go to my website, teresawills.com, under projects, there's MATHurdays, and I always leave the blank slides, the completed slides, and the entire video recording there. You should expect that to be there within the next 12 hours.
Excellent. Thank you so very much.
Sure
I
thing.
appreciate it. Okay. Bye-bye.
Someone said, do you ever use more visual support, posting questions during sharing? It was a little challenging following the verbal discussion. Yes, and it kind of also depends on my audience. When I have a group of 3rd graders, we are much more intentional about using the arrows. I have the students say that if they're going to talk about their slide, their arrow must move before they talk about that section. And so they get really used to that norm that before I can say during sharing, I have to move my arrow to the during sharing. And then if I move to somewhere else and I want to reference that, I would have maybe 2 arrows, or I might even have a section highlighted. And so when other students are talking about similarities and differences, they can reference the yellow arrow is during sharing, and the green arrow is different because it's talking more about verbal description. And a lot of our norms with different age levels, they just kind of evolved because of things that happened in the class. Let me think about seeing if I can write down some of those norms. And yes, I'd be happy to hold a session on that. I don't yet have a norms presentation, but I could definitely try and synthesize the different norms that we use. So stay tuned in June. That might be up there. All right, folks. Well, keep your math brains stretching and keep thinking about this problem. And I hope to see many of you next Saturday.